Welcome to the Answers Explained to the June 2023 Part C Chemistry Regents exam. A lot of times students neglect going over and practicing the short answer questions along with Part B-2. I'm so glad you're here. Don't ignore these questions. They're as important as the multiple choice. They will make or break you on the test. And with that, let's get started. So here we have a reading passage that goes along with questions 66 through 69. I'm not going to read to you the whole thing, but we're going to get right to 66. Identify 3 endangered elements listed in the passage that are classified as metals. Well, you know metals, hopefully, are on the left-hand side of the periodic table. You want to make sure that you have all of the symbols for these elements. If you don't know them, you're going to go to reference table S and then look and see where they are on the periodic table. That's key. New York State, with these questions, loves to give you the element name instead of the symbol to make you do a little bit of work. But you got this. Let's do it. I went ahead and circled the 5 elements. Helium is a noble gas. It's not a metal. Tellurium. This is where students might get confused. This is a semi-metal or metalloid. It's on what I call the staircase. It's essentially the dividing line between the metals on the left and the non-metals on the right. That leaves zinc, gallium, and indium as our metals. There's your answer. Question 67, explain in terms of. Anytime you see in terms of, in this case electrons, you better have that word in the answer. Why gallium and indium have similar chemical properties. Let's go back to the table again. Once again, I went ahead and circled gallium and indium. And yes, you can see that they are in the same group or family or column. But that's not the answer. Remember, it said in terms of electrons. The key is to note that gallium and indium have the same number of valence electrons, which is 3. That's the answer. Question 68, we're comparing the density of a sample of helium at STP to the density of the sample of tellurium at STP. Now, they didn't give us any information to calculate densities. What you need to know is reference table S has that information. Let's go there. Reference table S, we're going to look up helium. We go over to the second to last column, and we see that the density for helium is less than 1, right? 0.000164. Let's find tellurium. Tellurium element 52 has a density of 6.232. Well, it's obvious to tell then that tellurium has a greater density than helium. Finally, in this group or cluster of questions in 69, it says explain in terms of electron shells why the atomic radius of an atom of indium is greater than the atomic radius for gallium when both atoms are in the ground state. For this, go back to the periodic table. I circled gallium and indium with the electron configurations. That gives us the electron shells. Gallium has electrons in 4 shells. Indium has electrons in 5 shells. Question 70, we're looking to determine the percent composition by mass of nitrogen in nitric acid. The percent equation is on reference table T. If you forget, it's the part, which in this case is the nitrogen, over the whole thing, which is the gram formula mass, which they gave us, times 100. For the mass of the nitrogen, you're going to go to the periodic table and grab the atomic mass. We're going to take that, divide by 63, and times 100. Now, the question didn't ask anything about significant figures. Here is my atomic mass, 14.0067. We can round it then to 14 and use that in the equation. I set it up here. I actually typed it. You divide 14 by 63 times 100, and you're going to get 22%. For 71, you're asked to balance the equation 1 in the answer booklet using the smallest whole number coefficients. Balancing equations is a basic skill that you should have learned when you took chemistry. Let's review it. and figure out the answer. What I like to do is just take literally an atom inventory on both sides of the equation, right? Here's my dividing line. We'll start with N, which is nitrogen. We have one nitrogen on the left, we have one on the right. We go over to hydrogen, we have three on the left, and we have two on the right. They need to be balanced. In order to get the same number of hydrogen atoms on both sides of the arrow, I'm going to go ahead and multiply ammonia by 2, and I'm going to have to put a 3 in front of water. 2 times 3 is 6 hydrogens, and 3 times 2 is 6 hydrogens on the right. Great. But since I've balanced out my hydrogens, my nitrogens now are not balanced. I have 2 on the left, and I only show 1 on the right. What if I put a 2 in front of NO? All right, now that I've done that, the nitrogens are balanced, the hydrogens are balanced, and let's move on finally to oxygen. Oxygen's a diatomic. On the left, you see that it's 2 oxygens, and on the right, I have 2 times 1, which is 2 from the NO, and I have 3 times 1, which is 3 from the H2O, and 2 plus 3 equals 5. So I have 5 oxygens on the right. In order to balance this equation, and since this is a diatomic, 2.5 will do it. But there's a problem with that. It's not a whole number. You are asked to balance according to the whole numbers. Well, we got this far. The only thing left to do, literally, would be to go through these coefficients, the numbers in front, and multiply every single one of them by 2. Let's do that. This becomes 4. 2.5 times 2 is 5. 4 and 6. And now what we have is we have the lowest whole numbers for the balanced equation. Question 72, you're asked to show a numerical setup. That means you're going to show the numbers but not calculate the answer. For calculating the gram formula mass for NO2 produced in equation 2. Now, this was a misleading question. A lot of students got confused and had problems answering the question because it's guiding you to equation 2. And you see for NO2, there's a coefficient in front of 2. But that coefficient is just to balance the equation. When you figure out a gram formula mass for a compound, you just go by the formula. What does that look like then? You take and you list the elements that appear in the formula, the number of times they appear in the formula. Nitrogen is once, oxygen is twice. You get the atomic masses for the elements off of the periodic table. You multiply them out and you add them up. This is what they were looking for. And they didn't even want the answer, but I put it here anyway. For 73, determine the number of moles of oxygen required to completely react with 4 moles of NO in equation 2. So we're back to equation 2. In chemistry, we have a fancy word when we relate math problems to balanced equations. It's called stoichiometry. Really, all we're talking about here are ratios. You see I put a 4 above the NO and I put an X above O2. That's what's given in the problem. For the ratio, that's that whole number, lowest whole number ratio. In front of NO, it's a 2. And in front of O2, it's blank, but blank means it's a 1. There it is. There's my ratio. 4 over 2 is equal to X over 1. Just cross multiply and divide, and the answer is 2. Question 74. State the molecular polarity for each of the reactants in this equation. I got carbon dioxide and I have water. These are facts that you really need to memorize instead of trying to figure it out. Many students made a mistake here. Carbon dioxide is a linear molecule. It's one of the molecules with polar bonds, but it is a non-polar molecule. That's CO2. And H2O, polar bonds, and a polar molecule because it is bent shape. That's what we were looking for in 74. For 75, it says to draw the Lewis dot diagram for a molecule of water. Well, again, it's the bent shape. So here is oxygen bonded to hydrogen, but you don't want to forget the other valence electrons for oxygen. Those 2 pairs of electrons on oxygen also count as part of the Lewis diagram, shown here. For 76, based on table S, Compare the strength of attraction of the carbon atom for electrons with the strength of attraction for an oxygen atom in a bond between them. When they talk about the strength of attraction for electrons in a bond, they're talking about electronegativity. And when we're talking about electronegativity, go to reference table S. Carbon is 2.6 and oxygen is 3.4. That tells me oxygen has a greater strength for pulling the electrons towards itself in the bond. For question 77, state in terms of element classification why carbon dioxide is a molecular compound. Fancy way of saying a molecule. Well, look at the elements. If you need to, go to the periodic table. Carbon is a nonmetal and oxygen is a nonmetal. Therefore, they form covalent bonds, which makes it a molecular compound. For 78, write the empirical formula for glucose. Glucose, if you didn't know, is up here. Of course, we end up forming glucose in the photosynthesis reaction. For an empirical formula, that's the lowest whole number ratio of the atoms in a molecule. You got a 6, you got a 12, and you got a 6. The greatest number you can divide these through by is 6. So we can have an empirical formula of CH2 and O. We're up to question 79. We have an organic reaction in front of us here, and it says state the class of organic compound to which the product in the equation belongs. Organic compounds are carbon atom containing compounds. If we want to look for the class of this organic compound, we need to go to the reference tables. This isn't just a straight hydrocarbon because between carbons and hydrogens, actually not between, but besides carbons and hydrogens, we have this OH group. In order to figure out the class, that's going to tell us which one it is. Reference table R is a list of different classes of compounds that contain other atoms, again, besides just carbons and hydrogens. We're looking for OH, and you'll notice the second one here has the OH, and that makes the class an alcohol. Question 80, state in terms of carbon-to-carbon bonds why the hydrocarbon in the equation is unsaturated. If we look at the carbon-to-carbon bonds, these are double bonds. If it's a double bond, it's known as an alkene, and alkenes are unsaturated. In other words, you haven't maxed out the single bonds. You can open up one of the two double bonds and make this a single bond. For 81, identify the element in the product of the reaction that allows it to be classified as an organic compound. I already mentioned that, and that is, of course, carbon. We have just a few more questions to go. Just wanted to mention, if you're still hanging in there, good for you. You're working hard. You're listening to explanations. Some of these questions are tricky. This might be the difference between passing and failing, or getting, an A as opposed to a B. Keep working hard, and let's finish this out. For question 82, identify the liquid tested by the student that is most acidic. Well, when it comes to pH, most of you already know that the lower the pH, the more acidic. And we got to just make sure that we're dealing with liquids here. These are all liquids, so we're looking for the lowest, and that would be our lemon juice. For 83, it says state the color of brome cresol green after the indicator is added to a sample of lemon juice. The 2.1 for the pH is going to be critical. Let's go to the reference tables. Here we are at reference table M. I've circled brome cresol green, the range where it changes color, and then the color change. Now, 2.1 was the pH for the lemon juice. If you take brome cresol green and you throw it in lemon juice, you'll notice it's less than 3.8. That means that the color would be yellow. A lot of students have some trouble with dealing with this table, but you really don't have to. Let me show you just very quickly another way. 3.8 to 5.4 is in the middle of yellow to blue. In here, it's going to transition, and it's going to change, obviously, to green to go to blue. or you start at blue, a higher pH goes to green, and then yellow. 2.1, again, on a number line is down here, which makes it yellow. And you can do that with every single one of these indicators. For question 84, we're going to go to the answer booklet, and we're going to write in the formula for the missing product with the reaction of potassium hydroxide with acetic acid. We had a lot of students when we graded the test that found this question to be tricky, and it really doesn't have to be. This is a balanced equation. We can account for every atom on the left-hand side that needs to be also accounted for on the right-hand side. It's like taking your room and moving your furniture around, but it's still the same furniture. You've just moved it in different places. Quick, easy way to recognize this is that you have a base plus an acid, and it forms a salt plus water. This is a double replacement reaction, and H2O is the other product. Let's take a look at it a different way, though. I have potassium here on the left. If I cancel that on both sides, I'm done. Then I have OH. I don't see that yet. I have another H. I do have 3 H's here, but let's face it, this polyatomic, this acetate, and this acetate line up. So we can go ahead and cross those out. And what are we left with? We're left with an H and an OH, which makes H2O. We've made it to the last question, 85. Based on the pH value in the table, compare the concentration of hydronium ions to the concentration of hydroxide ions in distilled water. Well, in other words, they're asking us, hey, distilled water has a pH of 7. What does that actually mean? You know it's neutral, but maybe you forget sometimes what in the heck that actually, again, means. Hydronium ions, that's H2O plus H plus or H3O plus. Usually when we have an excess of hydronium ions, which are also hydrogen ions, we have an acidic solution. Conversely, if we have an excess of hydroxide ions, we have a basic solution. Well, if I have a pH of 7, what that means is the concentrations are equal. That ends it, Part C of the June 2023 Regents exam. I hope you found this helpful. Please subscribe to my channel if you haven't already. Lots of different things I throw out there related, sometimes related to chemistry, sometimes not. I'm so glad you went through this. Good luck on the exam. Take care.